Hello everyone, I welcome you all to this class. This is mathematics class, and today we are looking at this topic, initial value and the boundary value problem. Now we have introduced done the introductory part on this concept, ordinary differential equation. So under this ordinary differential equation, we are looking at this topic, initial value and the boundary value problem. Now you are given an ordinary differential equation. Now you want to know whether that given ordinary differential equation, whether it's an initial value problem or a boundary value problem, if before solving it. So you want to know which one it is. So let's know the definition of initial value problem and boundary value problem. Now, when an ordinary differential equation is given to you and it has a condition attached to it, if it has a condition attached to it, then that ordinary differential equation could be initial value problem or boundary value problem. But if it does not have a condition attached to it, then it is neither of both. So it will not be an initial value problem, it will not be a boundary value problem. But if it has a condition attached to it, then it means that you are either solving initial value problem or a boundary value problem. Now let's see what initial value problem is. Now if an ordinary differential equation is given to you and you have a condition attached to it, which we call the subsidiary condition, and if that condition, the condition is normally given on the dependent variable and its was derivative. You have a ordinary differential equation, a condition is attached to that ordinary differential equation on the dependent variable and its derivative. And if those conditions which is attached to the dependent variable and its derivative are given or at the same point of independent variable, at a single value of the independent variable, then we are going to call such problem initial value problem. So what is given on the board here, I said an ODE along with subsidiary condition on the dependent variable and its derivative, all given at one value of the independent variable, is called initial value problem. So both the condition on the dependent variable and its derivative are given at one value of the independent variable. Then we call such ODE problem initial value problem, and the condition will be called initial condition. So we call the condition initial condition. So but if you are solving an ODE problem and there is a condition attached to that ODE problem, and the condition we normally attach the condition on the dependent variable and its derivative. Now if that condition which is attached on the dependent variable and its derivative, if that condition is given at more than one value of the independent variable, then we are going to call such a ODE problem boundary value problem. So we say that if the subsidiary condition are given at more than one value of the independent variable, then the problem will be called what? At more than one value of the independent variable, the problem is called what? Boundary value problem. You can write it in short form like this. So if you are solving an ODE problem, if the condition on the dependent variable and its derivative, that is, the ODE problem has a condition attached to the dependent variable and its derivative, but the condition is attached at more than one value of the independent variable, then we'll call it what? Boundary value problem, which can be written in short form like this. Then the condition will be called the boundary condition. Now let's look at these two ODE problems. The first one is x prime of t. You know the one having prime is the dependent variable, right? X prime of t exponential negative plus exponential negative t x of t equals t squared. Now x, which has the derivative sign, is the dependent variable, t is the independent variable. Now the condition is attached on a dependent variable. Dependent variable is x, the condition is attached on independent variable and its derivative, right? But the condition is attached at what? A single point of the independent. The independent is t. In this place you have x of 0. In this place you have x prime of what? 0. The same point. 0 here, 0 here. So the condition on the dependent variable and its derivative is given at 1 point, 0 and 0. And that 0 is just that single value of that one value of the independent. Independent is t. So this kind of problem is called the initial value problem. If you want to check initial value problem, we don't normally check this value. What's the value? This value here, 1 here. Let me say here I'm seeing 1 here, I'm seeing 3 here. What we normally check is what is inside here, the value of the independent. That's what qualifies it. That's what makes it initial value problem or boundary value problem. So this, what is inside here is 0, and what is inside the derivative of x here is 0. So they have the same point, 0, 0. So is an initial value problem. Now looking at this ODE, y prime prime minus 2xy equals cosine x. Now the one having prime is the dependent variable. Y is the dependent variable because y is the one that has derivative sign. Then x, it means that x is the independent, right? Now look at this condition. There is a condition attached on this problem. They say that y of pi is half, and the y prime of 0 is 1. Now I told you that what you consider is what is inside in the dependent variable and its derivative. What is inside here is what? Pi. What is inside here is what? 0. Pi and 0, are they the same thing? No. So the condition on the dependent variable and its derivative are given at what? Two different points, right? So we call such problem boundary value problem. So thank you so much for being part of this class. See you in our upcoming class.